Flash floods are nature's sledgehammer. They strike without warning, devastating everything in their path.
It was like a bomb hit.
15 centimeters of water will knock over a person.
I really couldn't see how they were going to get me out.
Half a meter will carry away a car. 3 meters can demolish a building. Global climate change is making this kind of event more frequent and more extreme. In order to predict when catastrophe might strike, an army of weather warriors is going into battle to learn more about these destructive forces.
That's the stuff that's going to kill you.
Can they save us from killer rain? Over the past few years, Europe and North America have witnessed scenes of flooding reminiscent of third world countries. Is this something we're going to have to live with in the future as our climate changes?
Parts of the world are getting heavier rains more often than they used to. Chances of more flooding on more people and more urbanization means the potential for more catastrophe.
In the skies over northern Australia, fighter pilots and former astronauts are gathering to take part in one of the world's most ambitious weather experiments to help scientists find out what's going on in the atmosphere.
I don't think there's any serious doubt anymore that on a global scale climate change is with us. But the really important thing is what does that mean for regional areas, and what does it mean for severe events such as tropical cyclones and thunderstorms?
People in the tropics have always had to live with severe flooding. But is tropical weather now spreading to other parts of the globe? August 16th, 2004. It was a normal summer's day in Boscastle, Cornwall. Though some rain was predicted, no one could foresee the devastation which was about to take place. Boscastle sits at the bottom of a steep valley at the meeting point of 3 rivers. The main river is usually no more than a gentle stream which flows down from Bodmin Moor, through the centre of the village and into the sea. For local chef Scott Roberts, it seemed like a perfect day to go surfing.
I've been in for about 2 hours, and I noticed a big cloud above Boscastle, sort of starting to rain. It was raining so hard that you couldn't really see the difference between the sky and the sea. I've been in sort of really, really heavy tropical rain through Asia and sort of Indonesia, almost monsoon, as you could say, and this was 10 times worse. It's really, really heavy.
At 12:30, a huge storm cloud 10 kilometers deep was sitting over Bodmin Moor. Over the next 6 hours, it would dump 2 billion litres of water into the village below. That's a whole month's rainfall in a single afternoon. By 3:30, the river was ready to overflow.
I have seen it there before, so I wasn't completely worried at that point in time. It was only when it started coming through the wall behind the back of the kitchen that I thought, yes, we are in trouble.
But most people just looked on unaware of the danger they were in, even as the river was bursting its banks. Local musician Emily Morn knew nothing of the growing catastrophe outside.
Went walking yesterday morning, I didn't know which way I was going.
At 4:15, Emily stepped out into a scene from a disaster movie.
I mean, the water level was up to about here, and it was going so fast. I mean, they reckon it was about 60 to 70 miles an hour.
The street that we're standing on here is like a river. It was a river.
Very quickly, people started to get trapped in the floodwaters.
I tried to swim across, but the water was so forceful. It was the most terrifying thing. I clung onto here, so this drain pipe basically saved my life.
At 4:30, the fire brigade arrived to find that this picturesque village was on the verge of a major catastrophe.
It was just panic, chaos.
All the firemen could do was guide people to the upper floors of buildings.
Oh my God, look at everyone who'll come out.
Within minutes, they too became trapped by the rising floodwaters.
Because we wore a uniform, I think we were expected to know what to do. We were in just as much trouble as they were.
It just kept coming, but we had no control over nothing. And I've been in many serious fires, and it was the only time I thought I was going to die.
I'm not a deeply religious person, but I felt the only thing that I could do was pray. And I did.
With the situation beyond the control of the firemen, air-sea rescue helicopters were scrambled. These guys are used to extreme weather, but nothing prepared them for what they were flying into.
The valley opened up in front of us, and you could see the village and you could see the water.
Let's do it, hoist the crew.
That was when it really hit home.
The whole river had burst its banks and it was taking cars out of the car park, down the river, over the bridge, between all the buildings and all the way down the estuary out into the bay. You've got 3 valleys leading into Boscastle, so it was just a big funnel with somebody pouring a very big bucket of water in the top end.
1 hour after the river had burst its banks, the residents of Boscastle were clinging to the rooftops. The rescue was the greatest airlift on mainland Britain since World War II. It was a miracle that no lives were lost. How could this be happening in rural England? And why did no one see it coming? What weather forecasters do is measure current atmospheric conditions and then project into the future using computer models. For the Boscastle flood, the existing models were simply not detailed enough. If we're to be warned about where these destructive downpours will strike next, forecasters need to know more about the behavior of storm systems. On the other side of the world, in Australia's Northern Territory, an army of weather experts and high-altitude pilots is gathering for one of the biggest cloud studies ever conducted. It'll involve daredevil aeronautics in specialized planes, as pilots risk everything to fly as close as they can get to the eye of the storm. Climate change is playing havoc with our world. What's happening to our weather? Are Europe and North America facing a tropical future? On the other side of the world, a crack team of scientists and pilots is going into battle with monsoon storms in Australia's Northern Territory. They're using cutting-edge technology and high-risk aeronautics. Because in order to learn more about storm clouds, they need to take to the skies and fly straight towards them.
We're in the Northern Territory of Australia off the coast. Further north of Australia, along the equator in this area of the world, is what we call the warm pool. It's the oceanic area that has the warmest sea surface temperatures on Earth. And it's all the sunlight and everything and the warm surface temperatures that put all that water vapor into the atmosphere over the warm pool. It's a significant driver of global circulation.
It's early January, and 200 weather experts from 10 different countries have arrived in the city of Darwin for an intensive 4-week experiment costing $13 million. They've got a one-off window of opportunity to study storms during the Australian summer monsoon. The ambitious plan is to draw a circle 300 kilometers in diameter around Darwin and map the weather systems as they move through it. They want to surround the cloud systems, measure their physical properties, and create a 3-dimensional picture of how they behave. They're using radar, 1,000 weather balloons, an ocean-going laboratory, and a fleet of 5 specially adapted aircraft which fly around the storm systems gathering atmospheric data.
We really want to collect the most complete data set that we can of thunderstorm evolution, right from the very early stages of the storms through to when there's just the leftover cirrus clouds.
Thunderstorm clouds are like gigantic chimneys carrying heat and moisture into the air. Turbulent and chaotic, they can grow to a height of 15 kilometers. At the top, wispy cirrus clouds break off. Scientists know very little about these clouds and need to know more about their composition and life cycle.
What we hope to be able to do is describe what's really happening in the atmosphere, compare that with what the models are doing so that we can feed back and allow the models to be improved. Computer climate models are our primary tool for assessing how climate might change in the future.
The data gathered in Darwin will be fed into supercomputers like the world's largest weather simulator in Yokohama, Japan. By analyzing the tiny processes that go on inside storm clouds, the scientists hope to work out how these violent systems behave and then refine their weather prediction models.
If you look around, some of them, many of them are just small clouds. Every once in a while, you'll see one like that one over there will fire up. You can't resolve these clouds in the model. And so what you have to do is you have to estimate how many of the big ones you'll have, how many of the small ones you'll have, and everything in between, and how much of the area won't have any clouds over it. That's the game we play.
The top end of Australia lies in the tropics. It's closer to Indonesia than Sydney and shares the same harsh and unpredictable weather. In fact, as the experiment is getting underway, monsoonal flash floods are wreaking havoc just across the Timor Sea in Indonesia. Villages are being wiped out and hundreds of lives lost. If the scientists can improve their powers of prediction, they'll be able to save lives by warning about events like this.
What we observe during the monsoon here in Darwin is actually very typical for what happens over the tropical oceans. It's also typical for what happens in other monsoons, like the Asian summer monsoon. So it's a nice natural laboratory.
When it rains in Darwin, it really pours. Torrential rain can arrive in seconds, and the whole area is prone to flooding. This is the city of Katherine, south of Darwin. In 1998, 3 people lost their lives and thousands were evacuated when, after heavy rain, the Katherine River burst its banks. Australians in the Northern Territory have to live with this threat all the time during the rainy season. And along with the monsoon rain comes the threat of cyclone. On Christmas Eve 1974, Darwin suffered the worst natural disaster in Australia's history when it was struck by Cyclone Tracy. Over the course of 6 hours, the cyclone's ferocious winds razed Darwin to the ground, killing 65 people. Hector Ferreras was a teenager when Cyclone Tracy struck.
Spent some time diving and playing with dangerous things like crocodiles and sharks, and the cyclone is the one that shook me the most. My first impression was horrific, you know, to see the amount of devastation that I saw. It was massive. It was a whole town that got affected in one hit. You know, 15 years down the line, I still get goosebumps and I still cry sometimes when I drive down the road.
It is in this extreme and dangerous environment that scientists want to fly aeroplanes towards monsoon storms.
The cloud system that we have just over here is quite typical of what I'll be flying up against. In normal aviation terms, we're, as pilots, required to stay clear of this by about 20 miles. What the scientists will have me do is get close to that, probably around about the 5-mile mark, if not a little bit closer. They want us to go in through the cirrus outflow, and they want me to fly through it. So if you look further to the right there, you'll see that, that sort of light cloud, not the lumpy grey stuff which is the core of the thunderstorm. That I want to avoid totally.
Flying aeroplanes towards storm systems is a high-risk business. It requires great skill and goes against everything pilots are trained to do. Clouds may look harmless, but they contain huge amounts of raw energy, which can flip over an aeroplane.
It takes a lot of energy to evaporate water. Well, when you condense water in the atmosphere to make these clouds, you put that energy back out into the atmosphere. That's a lot of energy. For a good thunderstorm cell, the amount of latent heat energy released, if you could capture it, you could power a city like Darwin for a week. One thunderstorm cell, that's how much energy is released just because you're condensing water.
The Egret is a survivor from the Cold War. It's a West German high-altitude plane, originally used for spy missions behind the Iron Curtain. Its pilot, Alf Jonas, is well aware of the hidden dangers within these clouds.
Well, the big black grey clouds, they're the enemy, especially ones that tower up above 45,000 feet and stay well clear. They're the enemy. And the really low clouds are pretty much the enemy as well. But anything in between are just treated with a bit of respect, and it's a nice view.
Flying far below Alf, underneath the clouds, is the tiny Echo de Mona. It's a modified motor glider which measures conditions in the lower atmosphere. In particular, it looks at water vapor coming up from vegetation. It's piloted solo by scientist and cloud chaser Jörg Hacker.
I've flown more than 1,000 hours in similar environments for science, and you undergo the appropriate training. The danger is more that your engine will fail and that you have to, over the ocean, ditch the aircraft, or over the swamps, that you fall into the swamps and be eaten by the crocodiles.
This is crocodile country, and the swamps are full of the biggest man-eating crocs on Earth. One mistake by Jörg, and he's lunch. The star of the show is the futuristic Proteus, which is still on its way to Darwin from California's Mojave Desert. It's a unique research plane, designed in conjunction with NASA to fly twice as high as a commercial airliner. It's piloted by former astronauts. Mike Melville and Brian Binney were the first men to travel to space in a private spaceship.
40 seconds, a little left.
These guys know all about extreme flying. They now cruise the upper atmosphere in the Proteus, doing research into climate change.
It's designed to be able to carry a large payload underneath the belly. That's why it stands so high and is such a strange shape. We've been off the coast of China, we've been to Japan, we've been to the North Pole. We've been all over the place trying to understand global warming. We fly between 55 and 60,000 feet with these payloads, and we can stay up there as long as 20 hours at a time if we have to.
Although it's designed for flying in extreme environments, the Proteus is still struggling to make it to Darwin in the monsoon weather, and the experiment is missing its key player. It's a major cause for concern for the scientists on the ground.
I don't think I can think about it. It's hard for me to really comprehend what the implications of that would be in pulling that together in the next very short while. Then we'll have to act really fast. Okay?
The Proteus team are worried. They communicate with the plane by email, and they can see trouble ahead in the form of severe turbulence. "15 kilometers over Queensland, the Proteus is almost knocked out of the sky."
It seems like they've encountered some severe turbulence associated with some deep storms that developed in the Gulf of Carpentaria. These storms seem to have sent out a wave-like cloud, so they've had to turn back to avoid that cloud.
The Proteus has never encountered weather like this before and has to take evasive action. Has the Proteus met its match in the skies over Australia?
The aircraft was still controllable, but right at the edge of its control envelope. So it was necessary to just get out of there, get out of Dodge, as the Americans say.
These are anxious moments for the ground crew. Is the Proteus going to be able to ride out the weather? And will the pilots make it safely to Darwin? "2 days late and flying on empty, finally out of a misty sky, the four-winged superplane appears. It looks like an alien spaceship and is worth $10 million. Its precious cargo of scientific instruments is safe inside the pod, underneath the fuselage. And through the cockpit window, Mike Melville signals that all's okay. There is great relief among the team.
Let's go have a beer.
But the pilots have had a rough ride, and there are worries about what kind of conditions the monsoon will throw at the plane during the experiment.
The weather was manly enough to take the airplane from us, and we had both of us in there fighting for control of it. And we got through one of them and looked at each other and said, boy, that wasn't any fun. And about that time we hit another one, and off we went again. And so literally fighting to save the airplane, and after that one we said, hey, I can think of better things to be doing.
Oh, they're going to guarantee us it'll never happen again, so no, we're not worried about that. Yeah, that looked like a nuclear bomb to me on the screen.
After a perilous and nerve-wracking journey, the Proteus is now ready to join the rest of the fleet, and the experiment can get fully underway. With the monsoon building, they've got one chance to get it right. It's taken 3 years to organize, and the team are excited and exhausted in equal measure.
Combination of excitement, panic, you name it, fatigue. We're all, it's quite a mix. I think we're all very optimistic at this point.
We are ready to go, and it looks like we've got a great day to go, so we're looking forward to that.
It's early morning, January 20th. The teams of field workers are sent to the outer edges of the research area. 5 groups head off to the weather stations deep in the outback. It's a harsh and unforgiving environment. At bases to the north, south, east, and west of Darwin, the teams will carry out crucial atmospheric tests around the clock. These are remote stations, and they'll be out there for almost a month. It'll be a grueling schedule. It'll be hot, humid, and wet, and the living conditions will be basic. Once they're there, they cannot return. The rains are coming in, and the roads quickly become impassable. Some of the roads turn into rivers, useful only to the local fishermen.
It's a dangerous time to travel at the moment because of how rapidly the water can come up over the creek crossings. All the billabongs have broken free with the increase in rainfall, so all the fish that have been trapped over the dry season escape into the rivers and go down the creeks for spawning. And yeah, hopefully there's a few about at the moment, but I'm not having any luck today.
And as the monsoon gets underway, there is always the risk of a cyclone developing, which could wipe out the whole experiment, taking much of Darwin with it. Flooding is responsible for more than 1.5 million deaths each year, and killer rain can strike without warning. Over the past few years, we've seen freak floods in Europe and North America. We need to know what's happening to our weather. Colorado, USA, 1997. The small town of Fort Collins is hit by a deadly tropical storm.
It was like just nothing at the skies. It was just down.
It was like a bomb hit. I mean, and with the flood coming through and the way the water was, yeah, it just disintegrated everything.
I thought that hundreds of people were going to die.
Fort Collins lies at the base of the Rocky Mountains. The runoff water from the slopes is collected in irrigation canals which crisscross the town. The South College Trailer Park and Johnny's Liquor Store sit beside Spring Creek, which cuts through a railway embankment. Little did the inhabitants know that they were right under the eye of the storm. The night of the flood, an incredible 10 inches of rain fell in just 5 hours. The ground was already waterlogged, and the rain backed up behind the embankment.
You get 2 inches of rain in 1 hour over an urbanized area, and you've got a lot of water. You start to have a problem. 4 inches of rain over 2 hours, you got big problem.
Suddenly, a wall of water 20 feet high crashed through the embankment into the trailer park.
I looked out the window and my neighbor's trailer started sliding by. And the next thing you know, you hear glass shattering and people screaming.
We'll get you, just hang on!
Within minutes, the flood had created a nightmare of hazards for the rescue workers.
This is definitely getting worse behind us.
The flood had disrupted natural gas lines. It had broken loose electrical lines. You also have the power of water, the speed that it hurls things along, things floating underneath you that could catch onto you or hook onto you, and you can snag onto something that could drag you and pull you under.
At Johnny's Liquor Store, there was a serious gas leak.
I said, just get out, it's going to explode, it's going to happen right now. Everything we'd worked for our whole lives was gone because of that.
The water was getting deeper, it was the crashing of all these trailers, breaking apart. I just didn't see any way that people wouldn't die.
There was really no time to think about, okay, I might die here. All there was time to do was think about, how am I going to live?
5 people died in the Fort Collins flood, and the survivors bear the scars to this day.
My life changed to the point where even my life with my family was gone. 1 week later, my husband took his life.
Ian Leverett often revisits the site of the trailer park and the tree where he pulled his daughter to safety.
As I was pulling my daughter up, you know, she's all looking up at me and I'm looking down at her and she's all, Dad, don't drop me. I was like, there's no way I'm gonna drop you. For probably a good 3-4 years after the flood happened, I couldn't tell that part of the story with just completely breaking down and crying, you know?
In the case of the Fort Collins flood, the weather forecasters knew the rain was coming, but didn't know exactly where it was going to hit.
Thunderstorms are very small-scale events. They pop up kind of like popcorn, one spot or another. All the conditions were right. We knew the low-level moisture was there, the upslope up against the Front Range, upper-level moisture with the southwest monsoon. Everything was in place. We just didn't know where it was going to happen.
If another Fort Collins disaster is to be avoided, scientists need to predict these storms with greater accuracy. Back in Australia, the summer monsoon is unleashing millions of liters of water, creating lakes out of fields, rivers out of roads. It's the second week of the tropical warm pool experiment. And in the skies over Darwin, scientists and pilots are fighting an epic battle with the elements. The squadron of cloud-chasing planes is going head-to-head with the monsoon storms. As the monsoon builds, the developing weather systems are picked up by radar on the Southern Surveyor out in the Timor Sea, and the pilots are directed towards the incoming storms by the scientists.
Scientists are not pilots. They don't understand many of the sort of issues that I'm interested in. They direct us to be close to, but not in the eye of the storm. So I can see and appreciate what they're after, but I'm also looking after number one and the rest of my crew and the aircraft. So it's a real balance between the scientific goals and obviously piloting.
These are grueling missions for the pilots.
We're not only battling the elements on the outside, we've got elements on the inside. Up at 45,000 feet, it's so cold outside, about minus 50 to minus 60 degrees Celsius, that everything condenses, and I've actually got ice on the inside of the canopy.
While Alf battles the elements in the freezing upper atmosphere, skimming the Earth's surface below the clouds is Jörg Hacker.
We are trying to really push the limits, and the limits are pushed in several different ways. You are faced with lots of instrumentation problems. Most of the instruments you see on the aeroplanes are basically lab instruments. You have to tweak your instruments a lot to make them work under these conditions, and that doesn't always work. Humidity is bad here, and then the heat on top of this, you get even insect infestations in your instruments and a whole range of things which just make it difficult.
15 kilometers high, the Proteus is sampling wispy cirrus clouds.
What we're searching for are ice crystals at high altitude. We don't have to wear oxygen masks and we don't have to wear pressure suits. It's designed to sustain life up there just as it is on the ground.
The Proteus uses lasers to look into the clouds in the higher atmosphere. Particle images mounted on the wings measure ice crystals, moisture, ozone and gases. Lasers and cameras look into the clouds. Radiometers measure sunlight coming directly from above and reflected back from the clouds below. The Proteus pilots are surprised by what they're finding at these high altitudes.
Up there's usually not very much in the way of clouds. We're looking down on all the weather. But in this particular part of the world, even at 50, 55,000 feet, we're still in the clouds. These clouds go up much higher than they do in the United States. And this is a weather system like nothing I've ever seen.
While space-age planes are crisscrossing the skies above, down below they're using some of the oldest tools of the trade to measure atmospheric conditions. 1,000 weather balloons are released to help build up a three-dimensional picture of what's going on in the skies above Darwin. The balloons carry a tinfoil radar target and a device called a radiosonde, which measures heat, humidity and wind speed. These strange-looking objects are often mistaken for UFOs.
Yeah, they usually come back and sometimes farmers find them and want to know what they are, so we put little stickers on them to let them know that it's not a UFO or anything.
The balloons climb through the atmosphere for up to 30 kilometers, and they expand to the size of a house before bursting. As the balloon climbs, it immediately starts transmitting information about the atmosphere back to base.
Understanding clouds is kind of a bit of a problem at the moment, and so if you can get a greater understanding of the clouds, it's really small processes, that's why we've got such an intensive network, we'll be able to improve both forecasting and climate models. With the improvement of climate models, we'll be able to predict what the climate's going to do in the future.
The weather balloons are released into the atmosphere every 3 hours round the clock over a 4-week period. This may look like simple technology, but it's an unprecedented number of balloon releases and will provide an immense amount of data for mapping atmospheric conditions. It's January 26th, Australia's national holiday, and Darwin is celebrating. It's a glorious day, but within minutes the weather changes and the monsoon rains strike, causing widespread flooding. This is what the scientists are here to study. The catch is that the very weather conditions they want to find out about are causing problems for the pilots.
Not only do we have to worry about the weather at that point in the atmosphere at 40,000 feet, but I need to keep my brain thinking about what's happening back in Darwin. The monsoon season that we're in at the moment, the reason why we're here, obviously brings us a lot of concerns from a pure aviator's point of view, getting the aeroplane, any aeroplane, on the ground safely.
Flying any kind of aircraft into Darwin is difficult at this time of year, and all planes are required to carry an extra hour of fuel in case they have to be diverted.
Conditions are really killing us. We've had several failures of parts of the plane that we've never seen before. I think that was moisture related. So we are seeing the effects of humidity. There's a lot of moisture in the cockpit, and when we come back down, one of the most difficult things is keeping the windows clear, because we've been up where the temperature is about minus 100 F, and when we come back down here to where it's plus 100 F, that's a 200-degree change, and so the windows tend to fog up very dramatically.
The planes are getting drenched, and a lot of rain is bad for the instruments. Ironically, if there is too much rain, the experiment can't continue. The storm chasers are getting frustrated by the unpredictable weather.
It doesn't look that good. Yeah, actually, looking out to the east, it does not look that promising. So, all right. Yep, we'll have another go tomorrow, and we scrap today's mission. For our mission, we cannot really have rain, because that makes the measurements very difficult to interpret. It now seems as if the convection is restarting just to the east, and will move across the airport and across the planned pattern. So the rationale was to scrap the mission for today and try again tomorrow. So that's weather, I guess.
Of course, the locals know all about the unpredictability of the weather.
We're in the tropics here, and you just don't know when it's going to rain or whether you're going to get a game.
Those clouds look ominous, Paul.
It looks like a cumulus to me, Stu.
We're used to weather forecasters doing little more than just confusing us. We get the build-up, and then when we can't take that anymore, it dumps rain on us. And then we get a little bit of a dry spell, and then we get the cyclone activity around about this time of year. And then we get, to use a meteorological expression, the arse end of a cyclone. It'll drizzle for something like 2 weeks.
You can just about count on a storm every afternoon.
But not today. 10 days into the experiment, the weather changes from too much rain to not enough. The monsoon isn't behaving as it should. The storm chasers have nothing to chase. Millions of dollars of equipment are sitting idle, and the clock is ticking. For several days, there's no rain, only strong winds, and the atmosphere is dry. At the exposed station at Cape Don, the high winds are playing havoc with the balloon launches.
Try and get the level right so that it doesn't explode the balloon. That tower over there is causing us a lot of problems. Every time it's a near miss. But this time we managed to clear it, which is good. And now we go back to the computer and make sure everything's going fine.
The weather is behaving strangely. There's very little cloud. The seas are getting very rough, and a strong earthquake has been recorded north of the test area.
The other night I was in here and there was an earthquake at about 3 o'clock in the morning. The whole table started shaking and the computer screams. At the time I didn't know what was going on. I thought that I was doing something wrong or that the roof was falling in.
There are concerns that a cyclone is building off the coast of Darwin. The research ship is keeping watch, and the scientists and pilots are briefed about the danger.
It's forecasting a low to be southwest of Darwin with westerlies on Darwin. So there's some risk of cyclone development if it does move out into the Timor Sea and stay there for a few days. It's sort of just close enough to be a risk.
Well, the evacuation plan is to get everybody away from the remote sites, to get them back here to Darwin. Now, the aircraft cannot sustain strong winds even when they're on the ground, so they would be flying away even if it was a medium-strength cyclone. We would fly the aircraft to an airfield further south.
The next 24 hours will be critical. If a cyclone forms, the planes will have to be evacuated to Alice Springs in the center of Australia, and the experiment may become the victim of the very weather it's trying to analyze. The results could be catastrophic. The weather during the tropical warm pool experiment in Darwin, Australia is proving treacherous. There's a chance a cyclone might be building off the coast. It's a tense 24 hours for the pilots and scientists. They may have to evacuate the airbase and abandon the experiment. When Cyclone Tracy hit Darwin in 1974, the airbase was completely destroyed. By morning, it's clear that this time they're lucky, and the cyclone hasn't materialized. But the scare highlights the unpredictability of the weather in this part of the world.
This is tropical weather for you. It is unpredictable. Monsoons are unpredictable. That's why we're here, why the scientists are all here trying to get it all measured and trying to get it sorted so you can improve the predictability.
Prediction of real actual weather in the tropics is one of the holy grails of atmospheric sciences. It is still very difficult because tiny little differences in terms of pressure or water vapor make huge differences in the local weather. It is very, very difficult to forecast accurately, even on a day-by-day basis, what the monsoon is doing.
Now the danger has passed, the experiment gets back underway, and the pilots fly another 50 missions into these chaotic and changeable weather systems.
We've encountered turbulence like we've never seen before. It's really been an interesting experience coming down here and doing this. And I think the scientists are very excited to get the kind of data that we're able to get for them.
For the scientists, it's been the adventure of a lifetime.
It's not only exciting, it's what some of us live for. We work with theory, we work with measurements, we work with all kinds of things to try and figure out what goes on in the atmosphere. But there's nothing like actually watching these clouds, flying through them, feeling the conditions, because when you get back to the office, all you have is numbers.
Now the numbers need to be crunched and the data analyzed. Even though the scientists will use some of the world's largest computers, the huge amount of data will take as long as 10 years to process. In Yokohama, Japan, one of the world's largest computers is working on the problems of weather prediction. The Earth simulator is trying to predict global weather patterns for the next 100 years. It's built on an earthquake-proof base and has a massive 10 terabytes of memory. It's the second biggest computer in the world. It has 2,600 kilometers of cable and can perform more than 35 trillion calculations each second.
If we have enough knowledge, then we can make a perfect prediction. It is all to do with human lack of knowledge. Nature is an ordered system, so errors in prediction are not because of a chaotic system, but lack of human knowledge.
Dr. Sato believes that prediction of all weather events is, in theory, possible if we have enough information and a big enough computer. But will we ever have enough information to make foolproof predictions?
Certainly in my lifetime, I don't expect that sort of precision forecasting to be possible, even though we're getting better.
For the time being, the victims of floods remain skeptical about what the weather forecasters can predict.
I can't see how you could predict that happening. I mean, one minute it was just raining normally, and the next minute it flooded. You know, it was so quick. I can't explain how quickly it happened, and I don't know how they can predict that. I watched the weather that day, and it just said rain.
I still marvel at the fact of how it happened and just the sheer force of it all and how quickly it happened.
Disasters do happen, and you do have to react, and they're very real, and life is precious.
I always think there's every chance it's going to happen again. I mean, if it can happen once, then it can happen twice.
In Australia, those who risk their lives in the clouds have a more practical outlook.
Prediction of weather is up to God. He knows what's going on, and I don't think anybody else can predict weather. The scientists can have a better shot at it with all of their tools of their trade. Pilots should never attempt to predict weather. I always treat weather with the utmost respect, because that's the stuff that's going to kill you.
As the weather warriors head home from Darwin, perhaps we're one step closer to the holy grail of perfect weather prediction. But in the 10 years it'll take to analyze the data, how many more of us will fall victim to killer rain?